Hi everyone, my name is Chang. Today I'm going to teach you to solve non-routine problem using Polya's method. So let us read the question. A school has 100 identical pencils to pack into boxes. The boxes are available, come in three fixed sizes. There are 6 pencils, 9 pencils, and 20 pencils that fix with the small, medium, and large box respectively. Find all non-negative integer solutions x, y, z, where 6x plus 9y plus 20z equals to 100. Given that x represents number of small boxes, y represents number of medium boxes, and z represents number of large boxes. Among the solutions, determine which combination uses the fewest total boxes. Minimize x plus y plus z. So now we need to use Polya's method to solve the problem. So first step is understand the problem, then make a plan. Third, execute the plan, and the last, look back and reflect. So first, we need to understand the question first. So in the question, we know that the total number of pencils is 100. And the small box can fix with 6 pencils, medium box can fix with 9 pencils, and the large box can fix with 20 pencils. We also know that X represents number of small boxes, Y is the number of medium boxes, and Z is the number of large boxes. So what we need to do? We need to find all non-negative integer solutions first, and then we need to minimize x plus y plus z to find the fewest number that the boxes need to be used. Next, we need to plan how to solve the problem. So in this case, we can use algebraic reasoning to find the value of z, then x, and then lastly y. After that, we can create a table to test the integer values that make the right side of the equation is divisible by 3. Now, we need to start our calculation. The first step of our calculation is find the possible values of z. To find the value of z, we need to put variable z opposite to the variable x and y. So we write 6x plus 9y equals to 100 minus 20z. And then we write 6x plus 9y equals to 0. Why? Because the number of boxes cannot be negative. So the minimum value of the number of boxes is 0, means no boxes. And then we write 100 minus 20x smaller or equal to 0. Why we write like this? Because the value of z will not be larger than x plus y. If the value of z larger than x plus y, the number will be infinite. So 100 minus 20z must be smaller or equals to 6x plus 9y. And we know that 6x plus 9y is equals to 0. So means that 100 minus 20z is smaller or equals to 0. So we will get the answer, the value of the value of z is smaller or equal than 5. And the possible values of z is 0, 1, 2, 3, 4, and 5. Second step is to simplify the equation. The purpose we simplify the equation is to find out, after substituting the possible values of z into the equation, whether the new equation is satisfied or not satisfied to find the number of boxes. So now we can substitute the value of z into the equation. We can substitute from 0 to 5. So we can see that after we substitute z equals to 0 or 1 into the equation cannot be simplified or divided by 3 fully. But when we substitute z equals to 2, we can get a perfect equation, which is 2x plus 3y equals to 20. And then when we substitute z equals to 3 or 4 in the equation, they also cannot be divided by 3 fully. But when we substitute z equals to 5 into the equation will become 2x plus 3y equals to 0. So when z equals to 5, we can see that the right-hand side of the new equation is equals to 0. It means that all the pencils are in the large boxes because z is the number of large boxes. So there is no pencils in small boxes and medium boxes. So the value of x and y are equals to 0. Now we back to in front when the value of z is equal to 2. In here, we also need to do try and error. In this slide, we can see that When x equals to 1, y equals to 6. When x equals to 2, y is not an integer. When x equals to 3, y is not an integer. When x equals to 4, y equals to 4. When x equals to 5, y is not an integer. When x equals to 6, y is not an integer. When x equals to 7, y equals to 2. When x equals to 8, y is not an integer. When x equals to 9, y is not an integer. And lastly, when x equals to 10, y is equals to 0. So the possible integers of x, y, z are 162, 442, 722, 1002, and 005. So lastly, we need to find the minimum number of boxes need to be used. So now we need to calculate the number of x plus y plus z. No matter the size is small, medium, or large, we just need the numbers. So in this slide, we can see that we got 5 sets of possible integers. We just add it in each set. So the first set, we get the result of 9. The second set is 10. The third set is 11. The fourth set is 12. And the last set is 5. So which set is the minimum number? You can see that is the last set, which is 005, which is also x equals to 0, y equals to 0, and z equals to 5. All the pencils are in the large boxes, and to put these pencils, we need 5 large boxes. So we finally find out the minimum number of boxes need to be used. This is a table to make it easy to see the value of xyz. You can also see that the number of pencils in each size of boxes and the total number of boxes. You can also check your answer with plus all the number of pencils in each size of boxes. And the last step is look back. Just now, we have already calculated and find out the fewest total boxes used. So if you want to check your solution or answer is correct or not, you can substitute the values you get for each set or only the answer into the equation 6x plus 9y plus 20z equals to 100. If we got the correct answer, means that our steps are correct and the method we used are effective. Thank you for listening. See you again.